Okay, when we discussed accuracy, misclassification rate, sensitivity and specificity, etc., we assume that there will be a cutoff propensity specified, the default being 0.5, but you can specify whatever that you want. Okay, but no, well, of course, that's a good starting point. But we want to be able to also look at how well the model performs when the default probability is adjusted. Okay, so what if the default is 0.2, 0.3, 0.5, 0.8? How well does the model perform? So there is uh, there is some value in looking at the classifications that we get when we change the cutoff propensity. So most data mining algorithms have two-step process: compute probability, propensity, and then compare it against the cutoff value and do the classification itself. Okay, so the default value being 0.5. We talked about that. So we can use different cutoff values. Okay, typically error rate is lowest at 0.5. That's the reason why default is 0.5. Okay, now if you set up, and in our Excel example, we're going to look at how to set this up. Now, if you have the cutoff propensity and use formulas to determine these classifications based on the actual predicted propensity values, then when we change the probability here, these numbers will automatically change, and we can then set up a data table to figure out what will be the errors when these values change. Okay, and in my Excel video, I discussed this in more detail as to how to do it. But let's say we are now we have set this up, okay, and then we change the cutoff value from 0 through 1. Okay, so that means this cell will get populated by these cutoff values. Then when this value changes, then all of these numbers will change, and your accuracy and the overall error rate will get automatically adjusted, and here are those values. Okay, and when you plot, this is what you will see. In our data set, we had about 50% owners, 50% non-owners. So when the cutoff probability is 0, so that means everybody will be classified as an owner, so there will be an error rate of 50%. But if the underlying probability was smaller, then this value will be smaller. It will be more tilted. This graph will be more tilted. And in this case, if you set the cutoff probability at 1, then nobody will be classified as an owner, and once again the error rate will be about 50%, because there is, in the underlying data, there is 12 owners and 12 non-owners. Now the same thing continues. So if you have if you compute not just accuracy and overall error rate, and if you compute sensitivity and specificity, then sensitivity will be like this. So at 0, everybody will be classified as event, which means all the events will be classified as event. So your probability of an event getting classified as an event will be 100%. And of course, it will go down to 0. If the cutoff is 1, then sensitivity will be 0. So you'll go from 1 to 0. And specificity, okay, again, if you set the cutoff at 0, then everybody will be classified as event, which means the non-events will be classified as event. So specificity will be 0, and it will be equal to 1, because all the non-events and events will get classified as non-events. So you'll have 100% specificity at this point. But these two graphs are not all that interesting. What is interesting is what is called ROC curve, and we will look at that next.